My dear students, let me welcome you all to a new edition of physics. In this edition, we'll try to solve problems on chapter 1. The problems are of gradual difficulty. I'll start with very easy problems, then the problems will be a little bit more difficult. So let's get started. Problems on chapter 1. We'll start with very easy problems. Okay, what about the first problem? In front of you, we've got a circuit, a battery, and two resistors, 3 ohm resistor and 2 ohm resistor. Current through the battery is denoted by capital I, and that through the 3 ohm resistor is I1, and that through the 2 ohm resistor is I2. Okay, internal resistance of the battery is equal to 0. This is very important. And we want to calculate I1 and I2, also the total current. It's all easy. On this particular case, we've got two resistors connected in parallel to 6-volt battery. Okay, so the voltage of the battery, the whole voltage is applied across the two resistors. So it's all easy. I1 is equal to 6/3. It is 2 amperes. I2 equals 6/2. It is 3 amperes. And of course, the total current will be equal to the sum of both of them. It is 2 plus 3. It is 5 amperes. Okay. Another problem. We've got a circuit. And what about the circuit? It consists of a battery, but the value of the battery, value of the EMF is unknown. Internal resistance is given to be equal to 1. We've got a resistance of 2 ohm connected in parallel to 1 ohm. Current through the 1 ohm resistor is equal to 2 amperes. We want to calculate EMF of the cell. Okay, we've got two resistors connected in parallel. So potential difference across, yes, them is constant, it's the same. Potential difference across the 1 ohm resistor can be calculated. It's all easy. We know the value of the resistance. It is 1 ohm. Current through it 2 amperes. So voltage across the 1 ohm resistor is 2 volt. Voltage across the 2 ohm will be also 2 volt. And knowing the voltage and the value of the resistance, we can calculate the current. So current through the 2 ohm resistor, it is 2 voltage across 2, it will be 1 ampere. 1 ampere plus 2 ampere will give the total current. Total current multiplied by the total resistance will give the V battery. So let me do it once again. Potential difference across the 1 ohm resistance, it is 2 times 1. It is 2 volt. Potential difference across the 2 ohm resistor, it is 2 volt also. And now we can calculate the current through the 2 ohm resistor. It is 2 divided by 2, it is 1 ampere. 1 ampere flows through the 2 ohm and 2 amperes through the 1 ohm resistor. So the total current must be equal to 3 amperes. Total current equals 1 plus 2, it is 3 amperes. And now we can calculate, yes, the EMF of the cell. It is equal to V external plus V internal. Okay, V external plus IR small. So it is V external is equal to 2 volt plus 3 times 1. It will be 5 volts. So EMF of the cell is equal to 5 volts. Another problem. We've got a circuit shown in front of you. V battery here is equal to 4 volt. R internal 0.5 ohm. We've got a parallel combination, okay, which consists of 3 resistors 8 ohm resistor and another 8 ohm resistor and 4 ohm. Okay, and this parallel combination is connected in series to 1.5 ohm, and don't never forget the internal resistance of the battery is 0.5. Okay, calculate the current through current I1, I2, I3, and the total current I1 through the 8 ohm resistor, I2 through the 8 ohm resistor, and I3 then the total current. So the first step here is to calculate the total resistance. First of all, we'll calculate R equivalent of the parallel group. So 1 over R equivalent of 8 and 4, it is 1 over 8 plus 1 over 8 plus 1 over 4. Now I am calculating or trying to calculate R equivalent of the 3 resistors connected in parallel. 1 over 8 plus 1 over 8 plus 1 over 4, it is equal to, yes, 1 over 2. So R equivalent is 2 ohm. So R equivalent of the resistors 8, 8, and 4 is equal to 2 ohm. 2 ohm is connected in series to 1.5 and to 0.5 internal resistance. So total resistance of the circuit 2 plus 1.5 plus 0.5, so it is 4 ohm. Now we can calculate total current. Current, we call it through the battery. We call it the total current. So total current equals V battery over R equivalent or R total of the circuit. It is equal to 4 over 4. Total current equals 1 ampere. Current through the battery equals 1 ampere. Okay, to calculate I1, I2, I3, we need to calculate the potential difference across this parallel combination. Okay, it is equal to I, the current entering the parallel combination, times R equivalent of this parallel combination. So it is 1 times 2, it is 2 voltage. Now it's all easy to calculate the current through each resistor. Okay, so I1 is equal to the voltage over the value of the resistance, 2 over 8, which is 1 over 4. The same for the second, the other 8 ohm resistor. Okay, 2 over 8, it is 1 over 4. And 2 over 4, it is half amperes. Okay, another problem. Okay, in front of you, you've got a circuit. Okay, which consists of 10.5 volt battery of internal resistance 0.2. We've got 2 resistors connected in series, 4 and 2, and both of them is connected to 3 ohm resistor. And the parallel combination connected in series to 1.3 ohm. Find the current through the 2 ohm resistance and that through the 3 ohm resistor. Let me remind you with something. Actually, the 2 ohm resistor form with the 4 ohm resistor, one resistor of 6 ohm. Okay? To know the current passing through the 2 ohm resistor, actually it is the current passing through the 6 ohm resistor. Okay? Anyhow, we'll do it one by one. R equivalent of the 2 resistors, 4 and 2, they are connected in series, so 4 plus 2, it is 6 ohm. R equivalent of 6 and 3, they are connected in parallel, product over the sum, it is 2 ohms. Okay, 2 ohm is connected, R total of the whole circuit, it is connected to 1.3 in series, and the internal resistance 0.2, so the total resistance is equal to 3.5 ohm. Current through the battery is equal to, yes, it is calculated using Ohm's law of closed circuit. 10.5 over 3.5, it must be 3 amperes. We managed to obtain the total current. This current divides. Okay, to know the values, each value, when it is splits, we need to calculate the potential difference. Okay, so potential difference across the parallel combination equals the current entering, which is 3, times this, the value of the ohmic resistor of this combination, which is 2. So the voltage is equal 6 volt. The current through the 2 ohm resistor, your attention, it will be equal to 6 over 6, because 2 ohm and 4 ohm form just one resistor of 6 ohm. It will be 1 ampere. And the current through the 3 ohm, it will be 6 over 3, it is 2 amperes. Okay. Another problem. In front of you, there is a circuit that consists of 18 volt battery. Internal resistance of the battery is 1 ohm. And we've got 2 parallel groups, 2 parallel combinations. The first consists of 3 resistors, 4 ohm and 2 ohms connected in parallel. Another parallel combination that consists of 6 and 12. Okay, and your attention to the points A, B, and C. Find the current through each resistance. Okay. First of all, we'll calculate the equivalent resistance of the 3 resistors 4, 4, and 2. Okay, 1 over R equivalent equals 1 over 4 plus 1 over 4 plus half. It is 1. So R equivalent is equal to 1. And what about R equivalent of the second parallel? It is product over the sum, it is 4 ohm. Okay. R total of the whole circuit, okay, equals 1 plus 4, it is 6 ohm. And now we want to calculate the current through the battery. Current through the battery equals V battery 18 over the total resistance 6, it is 3 amperes. Potential difference across AB, across the first parallel group, it is the current times R equivalent of this particular parallel combination. So it is 3 times 1, 3 volt. Okay, potential difference across BC equals the current 3 times R equivalent of the second parallel group, which is equal 4, so the voltage is equal to 12. Now, since we managed to obtain the voltage, it's all easy to calculate the current. Voltage will be divided by the value of resistance. Okay, so I1 equals 3 over 4, I2 equals 3 over 4, I3 equals 3 over 2. This was about the first parallel group. And what about the second? I4 equals 12 over 6, 2 amperes. And finally 12 over 12, it is 1 ampere. Okay, another circuit, but it is a little bit more difficult. Okay, we've got 6 volt battery here of internal resistance, 0 ohm. The value of the internal resistance is equal to 0. We've got a parallel group consists of 2 resistors, 18 ohm resistor and 9 ohm resistor connected in parallel. And we've got another cell, 12 volt cell, and both of them acting in the same direction. So V total here will be the sum, 6 plus 12, 18. Okay, and we've got, yes, another parallel combination. Okay, which consists of 24 ohm resistor connected to the other branch consists of 5 ohm resistor and 7 ohm connected in series. So they'll form a resistance of 12. So actually the second parallel combination consists of 24 ohm resistor and 12 ohm resistor. Okay. And now we want I1 and I2. Okay. R equivalent of the whole circuit, 12 and 24 connecting parallel combination, product over the sum, 18 and 9 parallel combination, plus the internal resistances. So R total of the whole circuit, it is 18 ohm. Current through the battery, your attention, the EMF of the two cells are added together because they've got the same direction. 12 plus 6 over 18, 18 over 18, it is 1 ampere. Okay, so the total current is equal to 1 ampere. Potential difference across AB, potential across the parallel combination, which consists of 24 ohm resistor and 12 ohm resistor. It is equal to the current times 8. Okay, it is 8 volt. So now I1 is equal to 8 over 24, and I2 is equal to 8 over 12 amperes. Okay. Another type of problems. Okay. 3 resistances, 18, 9, and 3 ohm, are connected to an electric supply of negligible internal resistance. 3 resistances, 18, 9, and 3, connected to an electric supply of negligible internal resistance. So R internal is equal to 0. But there is something here. The problem does not mention the way they are connected, the way of connection of the resistors. Okay. Currents of 0.1, 0.2, and 0.3 pass through them, respectively. Find EMF of the supply. Okay, so we know the values of the resistances and the current passing through them, but we don't know how they are connected together. So the first thing to do here is to calculate the potential difference. And what is the point from this? Okay, resistances which have the same voltage, they must be connected in parallel. Okay, so potential difference across the 18 ohm, it is 18 times 0.1, it is 1.8 volt. Potential difference across the 9 ohm resistance, it is 9 times 0.2, it is 1.8, same voltage, so they must be connected in parallel. Potential across the 3 ohm resistance, it is 3 times 0.3, 0.9. Okay, so this is the expected shape. So R equivalent will be equal to 18 times 9 over 18 plus 9, product over the sum, plus 3, it is 9 ohm. Okay, so V battery equals 0.3, the total current, times the total resistance 9, so it must be 2.7 volt. Okay. A current of 0.2 amperes passes through a uniform wire when a potential difference of 3.6 volt is applied across its ends. Current intensity is given, potential difference is given, so value of the resistance can be calculated using Ohm's law. A current of 0.2 amperes passes through a uniform wire when a potential difference of 3.6 volt is applied across its ends. The wire is shaped into a rectangle ABCD such that the length of AB is twice that of BC. Wire is shaped into a rectangle. Length of AB, rectangle ABCD. Length of AB is twice that of BC. Find the equivalent resistance of the wire. If an electric supply is connected across AB and electric supply is connected across AC. First of all, we have to calculate the value of the resistance of the wire. It is V over I. 3.6 over 0.2, it is 18 ohm. 18 ohm is the total resistance of the whole wire. The wire is shaped, the wire is uniform, so resistance is proportional to the length. Cross-sectional area is constant, so resistance is proportional to the length. So resistance of the portion AB is twice that of BC, since length of AB given in the problem to be equal to twice the length of BC. Resistance of CB equals that of DA. And of course, twice the resistance of AB plus twice of BC equals the total resistance, which is 18. So RAB plus RBC equals 9. And this is quite logical because length of the portion AB and that of the resistance of portion BC, they form half of the rectangle, so the resistance is equal to 9. But the resistance of AB is twice that of BC, so we can say 2RBC plus RBC equals 9. And this way we managed to obtain the resistance of the portion BC. 3RBC equals 9, so RBC equals 9 over 3, it is 3 ohms. And of course, resistance of portion AB is twice that of BC, it is 6 ohm. And now it's all easy to calculate our total when we know from where the current enters and leaves through the group, the parallel combination. Okay. Here we've got a battery or a source applied across AB. Okay, so R equivalent is equal to 12 times 6 over 12 plus 6. Let me remind you with something here. The resistor 3 ohm and 6 ohm and 3, they all form just one resistance of 12 connected in parallel, yes, to 6 ohm resistor. So it is 12 times 6 over 12 plus 6, it is 4 ohms. This if the supply is connected across AB. What if it is connected across AC? And this way, we've got two equal resistors, each of 9 ohm connected in parallel. So R equivalent equals 9 over 2, it is 4.5 ohm. Another problem, but it is very important. Here we've got a table. Okay, we've got different types of wires, aluminum wire. Its length is mentioned, 178.57, area also, and resistivity at 20 Celsius. And we've got brass wire, length 200 centimeter, same cross-sectional area, 0.001 centimeter squared. Resistivity is given 8 times 10 power negative 8. And finally, silver wire, length 150, same cross-sectional area, and 1.6 times 10 power negative 8 is resistivity. So we've got aluminium, brass, and silver. The question is, which wire had the highest ohmic resistance? So we have to calculate the resistance for each one of them. Okay. And which wire would produce the greatest amount of heat if the wires were connected in series? Which wire would produce the greatest amount of heat if the wires were connected in parallel to a DC supply? We'll take it one by one. The resistance is calculated using the expression R is equal to rho E L over A. Okay, so resistance of the first wire, okay, all information are given, but length should be in meter, area should be in meter squared. Resistance of the first wire is equal to 0.5 ohm. Okay, this is the resistance of the aluminium wire. Resistance of the second wire, using the same formula, it is 1.6. The first 0.5, the second 1.6. Third, okay, 0.24. So the brass wire had the highest resistance. Okay. When they are connected in series, which wire would give the greatest amount of heat? This is very important. It asks about the power. Okay. This is very important. Rate of the heat produced is given from the expression I squared R. And when we are connecting the resistors in series, the same current intensity. So heat is directly proportional to the resistance. It means the higher the resistance, the higher of the value of the resistance, the greater the amount of heat produced. So the brass wire produces the greatest amount of heat simply because it has the highest resistance. But when connecting in parallel, actually it will be the opposite. Rate of heat will be given from the formula V squared over R. Why V squared over R? Because when connecting in parallel, voltage is the same. In this way, heat is inversely proportional to the resistance. It means the smaller the resistance, the greater the amount of heat. So the silver wire produces the greatest amount of heat. This way, we've come to the end of this edition. Until we meet again, my best wishes to you all. Thank you very much.